Hi, it's Miss Sullivan and it's time to move on to algebra. Now you've done algebra before, so really what this is like a reminder about what algebra is, particularly the rules. But I also want you starting to think about it in a slightly different light if it wasn't introduced to you like this in the first instance. So the reason we get lost in algebra is that suddenly letters show up. So what's with the letters? The letters are pronumerals, and you already know. Pronumerals represent a number. So we use X when we don't know what a number is. But that's really only the very first level of algebra, this idea of using a letter when we don't know a number. So what I mean by that is that I'd like you to start thinking about algebra as a language. And like all languages, when we use a different language, it helps to shift our thinking. So algebra shifts our thinking from the particular to the abstract. So it shifts our thinking away from individual mathematical situations to abstract mathematical situations. And it does this, there's layers of abstraction. So at level 1, I'm doing what we've done before, which is where X represents a number I don't know, where I'm finding a missing number. So this is a lot like if regular maths was a hyper-realist painting, so I could tell exactly what it was, that's a painting of a dog, then this level is slightly less real, a little more abstract, but still very, very clearly a dog. At level 2, we're devising formulas. We're using the language of algebra to come up with formulas. So that means that I can drop in any number as long as I can, and it's not really dropping in a number at that point. At that point, I'm gathering data so that I can come up with an outcome. For example, like speed is how far you've traveled divided by how much time it took to get there. Now, it doesn't matter what distance you traveled or how much time that was, that's still going to be how fast you're going. I can drop in different data and use the same formula. So now I'm painting like a dog. Look, it's recognizably dog shape, but it's harder to find. At level 3, it's basically, I don't even need to be able to see the dog at this point. At level 3, I'm unlocking the laws of the universe, and that's a really big deal. We'll move on to what I mean by that shortly, but algebra helps us think in abstraction. And just like with any form of abstraction, I can abstract something out at different layers. So let's start with this top layer, which is about finding missing numbers. It's pretty obvious. Things like 4 friends and a $240 dinner bill. Well, intuitively, I know that $240 divided by 4 friends is going to equal X. So each person's share of the bill. So if I divide 240 by 4, I find out everyone's share of the bill. We're going to pay $60 each. One little thing, and I'm going to add this throughout, is that note in the language of algebra that we don't tend to use the divided by sign. We like to express divided by as a fraction. It makes things easier to simplify a little later when things get a little bit more complicated. So sometimes, even when we're just finding a missing number, sometimes I can't get a nice, neat numerical outcome, particularly if I've got more than one variable. So in that case, what I'm doing with algebra is I'm helping to clarify a situation. So here's a situation. What'd you get at the shops? I got a pair of pants, a top, and I had $20 change. Yeah, good day. P for pants, T for tops, $20 change. This is called an algebraic expression. Essentially, I've just translated pants, tops, and $20 change into the language of pronumerals. So I've got P and T. Now, pronumerals, and here I've called them variables. That's a bit weird. What that means is they are pronumerals, they are representing a number, but they're variables because they could be really lots of different combinations of numbers. So I've got 2 variables and I've got 1 constant. My $20 change is not going to change. So in this algebraic expression, I've got 3 terms. Expressions with 2 terms are called binomial expressions, 3 terms trinomial, and more than 3 polynomial. It's really important that you write down these little sidelines because they're helpful for later. So just while we're talking about terms and ideas and basically the conventions of algebraic language, let's just remember if I bought pants and 2 tops and I had $20 change, in algebraic language conventions, we don't write the multiplication sign. So we don't write the multiplication sign because you can see that that's a bit confusing. It looks a little bit like an X. So we write pants plus 2t, so p plus 2t plus 20. And the 2, like we learnt in our last unit on index laws, is called the coefficient. So this is an algebraic expression with 3 terms, a trinomial expression. Okay, cool. But it doesn't really tell me much. It's cleared up a situation. What's going to be really helpful is if I can find some way of having an algebraic expression, it's when that becomes an equation. So if I said, how much money did you have to spend? I've got more data. How much money did you have to spend? I left the house with $170. So now I know that pants and 2 tops plus $20 came to $170. This side is 170. This side is 170. The equal sign literally means that this is the equivalent to this. And this is where things start getting lovely because you can start balancing equations. I can start using this algebraic equation. It's an expression up here because there's no equal sign. I don't have 2 sides, I only have 1. Down here, I can start balancing the equation to basically clarify this even more. So now I can start moving things around. I can take something from this side and I can move it to the other side. But remember, when I move it, it's got to become its opposite. So if pants and 2 tops plus $20 is $170, then $170 minus $20 equals pants and 2 tops. So pants, 2 tops is $150. Terrific. So if I just wanted to find out, now that's not super helpful because still that could be a wide range of numbers. I could have 2 tops, they could have cost $25 each, so I've got $50 worth of tops and $100 worth of pants. Or maybe my pants were like $75 and my shirts were like, 75 divided by 2. My shirts were like $32.50 each. So as you can see, they both come to, both those combinations come to $150. What's important here is that I can reorganize equations to find out different information. So if I just want to work out what those tops cost, for example, I know that I can reorganize this so that I've got 2 tops equals $150. Then I'm going to bring this one over to the other side, minus my pants. And if I wanted to clarify this further and I just wanted to find out, what did 1 top cost? I know that 1 top is going to be $150 minus that pair of pants, divided by, so if it was times 2 here, divided by 2 on this side. So $150 divided by $150 minus a pair of pants divided by 2 gives me the cost of 1 top. Now it's really important to note here, I can't simplify this. Even though I could say that 2 goes into itself once, 2 goes into 150 75 times, I can't simplify it because I don't know the cost of my pair of pants. So this figure is 150 minus P. And like I said, I can pop up several different numbers in here and it will still work. So I don't know what my pants cost, so I can't simplify that any further. But I've certainly clarified the situation. So at level 1, I'm finding missing numbers. So I'm finding missing numbers and I'm clarifying the situation. At level number 2, I'm devising formulas. So let's have a look at level number 2. I'll just move this over a bit. Hang on one tick. Level number 2. At level number 2, algebra starts becoming really useful. So let's say I want a pair of Nikes. They cost $240 and just for today, they're at 25% off. So to work that out, I know that 25 divided by 100, because that's 25%, times the cost of the shoes, $240, is going to give me my discount off, $60. So I'm going to get $60 off these pair of shoes while they're 25% off. Now that's kind of helpful, but just say I say that the discount percent is P, so this 25% is P, the original cost is C, and the dollars off is D, then I can express this idea as a formula. So that was the percent off divided by 100 times the original cost is my dollars off. Notice that I put the original cost over 1, and we're going to be coming back to that because it's going to help me see how it helps me simplify, so that P times C over 100 equals the dollars off. The percentage times the original cost divided by 100 equals the dollars off. I really want to talk about invisible ones for a second, just super quickly. So we've got to remember that any number is, another way to express it would be to say that number over 1, or 1 times that number, or that number to the power of 1. Just a little sideline because that's super helpful to remember when it comes to simplifying. Anyway, back to our formula for discounts. What this formula now allows me to do is substitution. So substitution means that it doesn't matter what the original price is and it doesn't matter what the discount is. I can pop it into this formula and I can find out how many dollars I'm going to get off. So let's have a little look. If something costs $150 and it's at 50% off, now P, my percentage off, is $50. Well, sorry, 50%. And the original cost is $150. So I know that P times C, so P times C, 50 times 150, divided by 100 equals my dollars off, equals 75, and I've just popped in here dollars. Don't forget to mention your units when you're working in maths. Or maybe it was $60 and it was 15% off. So the percentage off is 15, the original cost is 60, so I know that 15 times 60 divided by 100 is going to be my dollars off. So D in this instance is $9 off. Terrific. Just a little note, and I'll keep saying it, be careful with positive and negative numbers when it comes to substitution. When you substitute numbers into an algebraic equation, or even an well, really, substitution only works with equations, but when you substitute numbers into an algebraic equation, you've got to be really careful with positive and negative numbers. Just a little reminder. So, as you can see, formulas are super useful. So we used it at that first level, and at that first level, algebra was really good for helping us find a specific figure. It was also really helpful for clearing up a situation. So for clarifying something, I didn't come to the exact cost, but I've certainly got a much clearer idea, and I was able to rearrange my figures to basically try and find out different information from my original equation. Really important. We can rearrange, we can reorganize, provided that we're constantly balancing equations. We're making sure each side is still equivalent. So that's at level 1. At level 2, we were devising formulas, this idea of coming up with a formula for working out dollars off. And here, level 3, we unlock the laws of the universe. This is where algebra comes especially beautiful. If we have a look at something like this, here is a law of the universe. I know that any number plus another number equals a different number. And I know that that sounds like a strange thing to say, but it's actually something super important to realize and appreciate. It doesn't matter if I'm working with massive numbers or teeny tiny numbers. If I add a number to another number, I get a different number. Here's something else that's cool. It doesn't really matter what order I add those first and second numbers in. I still get a different number. So A plus B is the same as B plus A. That's a law of the universe. It's something I can't avoid. The only time that's not true is if I add a number to 0, in which case I end up with the same number. And again, if I start at 0 and I add a number, I end up at the same number. Kind of interesting. By the same token, if I have a number and I multiply that number by 1, I get that number. Or 1 and I multiply it by that number, I get that number. Doesn't matter if it's the number times 1 or 1 times the number. This is a truth that cannot be avoided. It's called identity law. It's a truth of the universe. It's just how, it's a fact. It's something that I cannot escape. Let's have a look over here. I know that if a plus b equals one number plus another number is a different number. I also know that one number times another number is a different number. And very much like addition, when I do multiplication, it doesn't really matter what order these two numbers go in, I end up with the same number. That's called commutative law. And it's kind of significant because it's really important to realize that it doesn't work with minus and it doesn't work with divide. So if I've got this number, take away this number, it does not equal that number take away that number. Let's have a think about that. If I've got 6 minus 3, that is not the same thing as saying 3 minus 6. It doesn't work the same way as these ones work. It's a truth of the universe. Very much like so. Looking at addition as the opposite of subtraction, looking at division as the opposite of multiplication, saying A divided by B is not the same. It does not equal B divided by A. They're very different things. 6 divided by 3 is not the same as 3 divided by 6. Commutative law does not apply to subtraction and to division. Another important law to remember, just so that we get this idea of using algebra to seriously unlock the laws of the universe, these are things that we cannot escape, is things like inverse law. Just the last one I want to have a talk about because it's really good for algebra. A plus negative A is the same as negative A plus A, and they equal 0. So a number plus its opposite is the same as a negative number plus its opposite, and they come to 0. Inverse law. And one last law of the universe. A number divided by 1 multiplied by its reciprocal. You remember that from when you were little and you were multiplying fractions? So this is called its reciprocal, is the same as saying, just like above, the reciprocal multiplied by the number, and it always equals 1. That's called inverse law. So what I'm really hoping I did then was jog your memory about some important stuff to do with the language conventions of algebra. So just a little reminder, things like we use fractions, not the divided by sign, this idea that this is an algebraic expression that has 3 terms, 2 variables, and that these numbers, these ones that don't change, they're constants. The concept of 2 terms being binomial, 3 terms being trinomial, and more than 3 terms being polynomial expressions. They've got their own names. The idea that we get rid of multiplication signs where we can. And when we see a variable expressed like that, we know that the number is called the coefficient. And a reminder that the equal sign turns an algebraic expression. The algebraic expression becomes an algebraic equation. Something that I can then start to work with by balancing. So we work in layers of abstraction from the really basic, finding a missing number, to clarifying, to using algebra to develop formulas that I can apply to all different data. I substitute data in, and it makes numbers work in a predictable, makes life work in a predictable fashion. Remembering our little invisible 1 laws, and then obviously this third and final level of algebra, which is unlocking the laws of the universe. We've learnt commutative law, identity law, and inverse law. Excellent.